Welcome everyone, I'm Philippa Jefferies from River Publishers, and today I'm talking to Michele Albano, Associate Professor at Aalborg University and new series editor for our book series in energy management. He has extensive experience in various areas like cyber-physical systems and energy flexibility, and today we are talking about his experiences and research interests as well as the book series. So thank you, Michele, thank you so much for joining me today.
Thank you for having me.
So first off, perhaps could you start by talking a little bit about how you got started kind of specifically in energy and your research now?
Well, it started when I was studying for my master degree in computer science. I worked on wireless sensor networks, which are embedded systems that I used to collect about the environment, to check how the environment is working, the energy consumption, etc. And in that context, since they are usually embedded systems, a battery, it's important to manage their energy. And well, that was my master thesis. I worked to optimize how they use energy, those small embedded systems, and I went on with that on my PhD studies. Then I had my first postdoctoral stay in Aveiro, in the center of Portugal, in the Telecommunication Institute. And there I studied how to save energy on mobile phones, and also, finally, I started working on the smart grid, in particular in terms of communication protocols. In 2012, I moved to the Polytechnic Institute of Porto in Portugal as a research scientist. And they told me, come to work on the middleware, but not in the sense that you usually do in computer science. It was the common information model. That is a middleware for electricity. So instead of being something for computers, it's a way to describe your appliances, your energy production, and to associate them with metadata so that the data you collect and the commands you send to your appliances have also a description of what you're doing. And by the way, it's a design standard developed by the International Electrotechnical Commission. So it's totally something for electrotechnical machines. It's not for pure computer science. And so instead of using energy-saving techniques for ICT, I was using ICT to save energy. Since, the main idea in that case was to work on domotics, this old keyword that we don't use anymore, to help the smart grid. And I spent 7 years in that institute using embedded devices, Internet of Things, cyber-physical systems, with the two main parallel tracks. One was industrial informatics, so predictive maintenance of machinery, improving control on factories, and on electrical systems, like the to advance the convergence of what to use in terms of appliances for the smart grid. And the other track I was working on was the smart grid, pure and simple. So I studied that from many different point of views. How to measure the consumed energy, how to sense what's happening, how to predict the energy we're going to consume. And in that place, I work with on international European research projects with so many partners. For example, I work with Fagor, with Acciona Construcción from Spain, with Philips from Netherlands, with 3 different departments, medical systems, consumer lifestyle, and electronics. I work with Infineon, Atos, Airbus, Ansaldo, and also with some universities. Lulea, University of Technology, Tampere University of Technology, and Aalborg University, which in 2019 offered me a position as here to be a professor. So first assistant and then associate. And Aalborg University is the university on energy in Denmark. We are famous for computer science. We are quite strong, but especially for energy. The energy department here is very strong. And in fact, that's what I'm working at now. My current research projects are DOM-OS, Domotic Operating System, and actually is a a smart building technique to have the secure connection of devices and appliances in smart buildings, especially to optimize space heating. So, energy. And the other actually is Fever, that is about flexible energy production. And in fact, Aalborg University was the university that created the concept of flex offer. You are buying energy from the energy producer, but you are selling back flexibility. That means I'm okay with consuming the energy for my washing machine right now in 2 hours, in 4 hours. And so you get in exchange tokens that you use for every discount on your bill in the end. Since the big thing is to shave the peak consumption. Since probably many people working in energy know that if we have a peak of consumption, they have to switch on peaking power plants, which are more expensive to operate, they pollute more, etc. So if you're able to move the consumption from the peaking hours, shave off the peaks is much better. And that's what I'm working at now. I'm working on the one side, integration of smart buildings in smart grid, and the other side, to create energy islands and in general self-consumption areas, neighborhoods, etc., to maximize how you consume the locally produced energy and how to move around the energy consumption, not to have peak consumption.
And what are the kind of real challenges of reducing that peak of consumption and making it more flexible?
Well, I would say regulations. Something is moving in Europe. That's very good. Also because we know that we are in an energy crisis. And that gave one more push to Brussels in the end, to try to have common regulations all over Europe. Because we need them. Because if not, for example, in Germany, not in all of Germany, but in most Germany, if you want to sell your energy, you must buy a license to be an energy trader, and it's super expensive. So the small producer cannot sell energy. At maximum, it can consume its own energy, and that limits the integration of distributed energy resources, and that's quite a big limitation. Then other big issues, standardization. Here you heard the word Matter, the new protocol that they invented in December. Well, as usual, instead of saying we have too many protocols, let's try to find one of them and use them. No, they said, let's invent one protocol. And that can be an issue because if we don't have a common protocol between appliances, within all over the smart grid, and even for the production of energy, it's very hard to be able to make everything work together. And that limits the integration. That's also one problem.
Okay, so rather than kind of more from a technical point of view, it's more of a policy, like you say, protocol issue.
Yeah.
Okay, interesting.
Yeah. Everything else is moving. Probably you know that everybody's working for the digitalization of everything, of PA access, public administration access, of energy consumption, energy production, pretty much everything. And that's something very good because you can do a lot with the data. And if everything is digitalized, you can remote control your heating system, for example. You can collect data, and that can be a game changer. Since my dream would be that my house predicts how much energy I will consume tomorrow based on weather forecast and my usual behavior, And so it buy in advance the energy I will need while the energy is cheap. Store something like that, for example, in the battery of an electric car, and then this way I optimize how much I spend, and also I shave off my consumption peaks. And then I can tell to my system, my dream system, by the way, we are talking about energy management, so it's similar to what we are doing with the book series. And by the way, tomorrow I go on vacation, so I click, and only when I click, the system will know that is not normal behavior. And for doing that, you need the AI to predict how you usually behave, the AI to predict, or the models to predict the weather. You need connection to the energy market. You need the right, the small consumer, to buy your energy whenever you want. You need technology for the storage of energy. And everything must be interconnected, which is exactly the issue that we were talking earlier, that we need common regulations and common protocols for everything to work together.
Okay, interesting. I'm interested because you say like by collecting this data and kind of predicting and using kind of smart technology to reduce your peak consumption. You started this kind of conversation by talking about how you came into energy almost by starting kind of computing and trying to reduce the energy you're using. Will using all this kind of technology also have quite a large power demand though? Or would it be outweighed by the energy you're saving?
You mean you want to use technology too? Sorry, I didn't get it. I had a problem with the connection. Can you repeat the question?
Yeah, so you started this kind of conversation by talking about how you started in computing and was looking to reduce the energy for that, and that's how you got kind of into using it to reduce energy. I'm just wondering whether kind of like using all this new technology and the data processing and things like that, surely that will use quite a bit of power, and whether that kind of is outweighed by the energy you'd be saving by using this kind of thing.
Yeah, I understand your point. Yeah, for sure, if you want to predict the weather locally, you are over-consuming your energy. And that's why some of the computation must be done for the public. For example, the weather forecast system cannot be run by yourself. What you can do by yourself is to have some kind of easy to execute, for example, a neural network to predict how you behave, given that tomorrow is Saturday.
Yeah.
That is it doesn't have to be perfect. It must be good enough to help. And this kind of trade-off between the energy you consume for optimizing the energy consumption and the energy consumption itself can be a problem. But things are moving because every few months we have new processors that are cheaper in terms of energy consumption. And you have novel techniques. And I'm also working currently on energy-oriented programming, where you program your system and actually you take into account how much energy you will need to consume given what you program it. And that's also something that is, it was quite interesting some years ago, but people got out of the topic. And now, given the energy crisis, it got back to be very important. There are a number of research groups all over Europe, all over the world actually, doing energy-oriented programming. And that will be quite important in the future, I think.
Yeah, we've mentioned this energy crisis a few times. Is that really driving research in this area at the moment?
Not the energy crisis, because it's too new, let's say. But the climate change has been here for a long time. And that brought Europe to invest heavily on energy saving, on those kind of technologies. Now, the energy crisis maybe will lead us to invest more on the topic, maybe
Mm-hmm.
in the medium term. But it's okay. We are talking about funding in the end, because Europe decides what people will research on by allocating the funding money. And Europe was already very heavy on energy saving. So the energy crisis here,
Mm-hmm.
it can be a problem. Still, Europe was already doing a lot
Okay.
to help saving energy. It's been quite important for a long time.
Mm-hmm.
And I didn't check the current research agenda regarding energy, but for example, 2 years ago, I was one of the authors
Mm-hmm.
of the agenda they used to decide how to allocate money. The big issues were integration of
Mm-hmm.
small and medium producers in the
Okay.
grid, and flexibility. That was one of the
Mm-hmm.
research topics 2 years ago. And I don't think that energy crisis will change us that much.
Okay. It's still a key research area, key concern
Yeah,
for all countries. Yeah, not just in
yes.
Europe as well.
Yeah, exactly, all in the world. Yeah.
Okay. Well, great. We're kind of running out of time, but thank you so much, Michele, for joining me and having a chat about your research. And yeah, welcome to River Publishers. We're so pleased to have you
Thank
as
you.
book series editor.
Thank you, my pleasure.